look, the data world has got an entire fabric and we are stuck with just RAG. So hey, hello everybody. Good evening and welcome once again. And thank you for giving me the time of your day to learn about Foundry IQ. Okay, a little bit of trivia, right? So I was there in person in San Francisco doing the Foundry IQ booth with the product manager of Azure AI Search, Pablo Castro. So I mean, our MVP friend here would know his name. Yeah. And the interesting thing was, I asked him, like, why Foundry IQ? It's advanced agentic RAG. So why Foundry IQ? And he told me a very hilarious answer. He was like, hey, look, the data world has got an entire fabric and we are stuck with just RAG. So which is why, Foundry IQ just makes so much more sense. And come to think of it, right? I mean, the trivia aside, RAG, as we knew 2 years, 3 years ago, before the onset of GenAI, was just a piece of cloth, right, for all people. And now it's the cornerstone of most of your GenAI knowledge searches, knowledge management. In fact, without RAG, you don't have a GenAI project, if I might say. So, of course, you need a lot of surrounding stuff for that. But which is why, it brings us to our today's session, which is advanced RAG accuracy with Foundry IQ. All right. And I hope you're all well fed and watered, and I will, not keep this discussion boring. So we'll have a lot of demos, a lot of interactions, funny AI answers, and we'll keep it interactive. All right. About me, because it's all agents. So I'm a senior AI agent at Avanade. Microsoft AI MVP, speaker, blogger, author. You can connect with me on my LinkedIn handle or hit me up on my repositories on GitHub. Okay. So look, I don't want to go down the same old of AI is now imperative. And, we all know that it is a 4.4 trillion industry projected to grow and, high impact, high profitability, all of that, right? Okay, but then we all know about this new MIT report, which shows that 95% of the GenAI pilots, they deliver zero ROI. And then, most of them fail to make it to production, right? And most of the common reasons we've gotten so far are, look, at the pilot stage, it is all very impressive, right? I mean, you do a small POC, you can ingest a few hundred documents and, you can extract rich text. But as soon as it comes to real world practical scenarios, it falls short, and we have seen it firsthand, so I'm not just going to talk about the glory of RAG searches and the glory of AI agents. I'm also going to show you some pitfalls, like some real scenarios in which we need to bolster your RAG searches and GenAI agents with some, tactical strategies. All right. So we, one of the other reports, we also has said that, 40% of organizations, they say that they have deployed AI tools, but then only 5% of them see any tangible benefits because lack of adoption, because the AI world is so ever changing, and most of those POCs are not adapted to scale. They are there to solve a very small business problem, and then as the technology changes, you find there are further more lucrative use cases you can solve, and then there's no interest or there's no usage of that pilot. That just remains a pilot, right? There's no tangible benefits out of that. All right. Why it is so hard? Lack of strategic vision. There are risks, poor data integrity, right? Scalability challenges in people enablement, right? And of course, there's also this push and pull between low code and no code, right? So all of my pro code programmers, pro code champions, they will be like all towards using Foundry, using your semantic kernel frameworks, code first patterns. So whereas the low code supporters, proponents will be, everything Copilot Studio, everything M365 Copilot, everything Power Automate, D365, and all of that. So that also creates a bit of adoption challenges and adoption at scale in your enterprises, right? And Again, there's so much of risk because you don't know what kind of data is going out. You don't have a lot of control over models which are locally available in your regions. You have global standard deployments, prompts stored outside of your region, so that also creates a lot of challenges. Okay, right? So let me give you a sample demo which we had created for a particular fictitious bank, right? So they wanted their call center operations to be automated using GenAI. So let me show that concept video, and then let us come to the actual implementation. So a POC versus a real life prod implementation, and let us look at some of the challenges, and then we come back to Foundry IQ. All right. So this was a concept video we created for fictitious bank, and the use case was we wanted to AI power their call center analytics use cases. So usually you get this call from banking members or non-members, and there are inquiries about home loans and credit cards and reporting double transactions. And then the operators need to visit the member policy membership portfolio. They need to extract the details. They need to dig into those transaction charges. They need to route you between different departments, and you might need to repeat the entire story of why you're calling. There was a credit card stolen, double charge on my credit card, so on and so forth, right? So can it be automated? I have my banking policies, my processes, my retail products at one place, and when an inquiry comes in, can the bot pick it up? Can the bot go and securely retrieve the member details if that caller is a member in the first place, and then tag it with the policy information which I have, and give me an intelligent answer, or at least point me towards some intelligent documentation, so that the agent as well as the caller, they do not have a repetitive experience, like repeating the same query and then having to answer the same queries over and over again. All right, so have a look. So what happens is, this is real time call transcription happening, right? So on the left hand side, you see that this is the actual banking caller agent. This is the calling end user, and the call is being transcribed live. So the AI bot, of course, with user permissions, is listening into the conversation. And now it has understood that, the customer's inquiry is likely about transaction dispute. So now the GenAI powered bot is going into your policy documents which are indexed in your Azure AI search. It is getting the source of the ground truth, right? And then it is giving you a guide to follow for the further steps. So it generates a checklist to guide the agent. All right, so it has generated that checklist, and now the agent will be able to check off one after the other, right? So let's go here. Yeah, so the checklist, the caller now follows the GenAI generated checklist and asks the user the questions which he or she needs to substantiate that this is indeed a fraudulent transaction. And then again, there are suggestions. So it shares tips to help agent delight the customer, that please inform that there will be a callback. So it's also rules of engagement, not just parroting the policies back to the user, but also rules of engagement that do remember. And then in case the customer might ask a question which is deviant from the transaction, right? So when do I get the refund? So here there's an ask button, which means the bank agent can directly click the ask button. So you see, when can I generate the refund? That question was directly passed by the banking agent to the GenAI bot, and now the GenAI bot is able to understand the question, again triage it, go to the policies, fetch the information, and so on and so forth. Okay, so all done. Then what we can at the end of the call also do is have a post-call checklist, right? Like, what did you do? What was the caller inquiry satisfied? What are some of the checklist on my end as well as the caller's end? So a good summary and a rating of how did you do, where did you miss, what did you do well, what did not go well, those kind of things, right? So post-call checklist, and then coaching tips, and yeah, so that is, sorry, yeah, and so that is your targeted target state, right? So this is what your target state looks like, right? This is the actual practical use case for a GenAI powered bot. And then as you can see, it touches diverse data sources. It has the policy information, it has the customer information, it has the banking products retail information. So it could be the banking SharePoint pages, content management pages, web pages where you have the banking products listed, and the secured CRM system of the bank, from where it is pulling out all that details and harmonize the data together and then answer you the questions, right? Impressive, right? Pretty impressive. I mean, if you look at this in the POC or demo format, pretty impactful. Okay, so now let's go to the actual implementation, what it looks like and what are some of the pitfalls. Okay, so are you able to still see it? Oh, perfect. Okay, so financial education, and then before we move on, from one agent to a spectrum of agents where we have no agent, single agent, multiple agents, semi-autonomous agents, and then autonomous agents. So this use case falls in the multi-agentic use case, where agents are collaboratively able to solve complex tasks together, right? So you have agents which is fetching your user information, policy information, website information, agents which are able to do the summarization, post-call analytics, call transcription agents, right? So these are multi-agents working together to solve a problem, right? So our use case falls somewhere here. And then we have the semi-autonomous, autonomous at a proper level where organizations are at a level where they can let the agents run themselves without human in loop. Okay, now expectation versus reality. So before I jump to the expectation versus reality, this is one of my favorite jokes, right? So yes, so what is the use case? Use case is one of the use cases. Yes, walk into a bar and order beer. Okay, now we have test users or test cases when we want to mock up something or when we want to demo something. Yes, tester walks into a bar, tester crawls into a bar, tester hops into a bar, tester dances into a bar, he slithers into a bar. So we explore all the options of, oh, I have website data, I have CRM data, I have so many data, and have tested all those information sources individually using GenAI. They work fine, perfect, right? Then I do negative testing, like I do hallucination. Does it hallucinate? Does it, ground truth, accuracy? But I'm testing individual agents together, right? So then I can do all the testing, negative testing, which I want to. But then I'm doing it against a corpus of test data which I've generated, right? So I have certain evaluation data which I run it against, and I get these results, okay? But then when you release the bot into production, right? So a normal user walks into a bar and asks, where's the washroom? Which is what happens. Like in real case, the user can come and ask you a, complex question, which is like, how can I close my bank account? Or, what are the advantages of investing in your bank versus a credit card of some other bank, which requires more than just the RAG architecture, which you have tested into. It requires your treasury rules, what happens, if I am a citizen of US and I also have a investment account with your bank. So now this requires more than just the documents which you have ingested inside of your search, right? And then what happens is just the use case explodes. It hallucinates, it gives you weird answers, right? So we already know, right, high level functional capabilities to achieve that GenAI for a search bot is, you have your source data, you have ingestion pipelines, you will create vector embeddings, you will have prompts, you will have LLM, and you will have the output, okay? But most often this is the recommended architecture, right? Most often what happens is, setting up enterprises for GenAI success, what organizations and end users often feel is, this is what they expect, right? Like feed all the multi-model data to the LLMs. The LLM is a super powerful brain. It will process the user queries against all the data, and all your questions are answered, right? Okay. But then how the LLM brain is actually curated, it's not just the LLM alone. Yes, there is the power of LLM, but how that brain is curated is there is prompt tuning. So you have, champion challenger approaches, you have self-ask, you have filtration, you have guardrails, right? You have contextual awareness where you give rules, domain knowledge, you give enterprise business glossary. For example, you have abbreviations, right? So what is, for example, SSO, so single sign-on, or in terms of banking, you have contract-related abbreviations, you have tax-related abbreviations. So you need to go get those enterprise business glossary terms. Ontology, which is like hierarchy, taxonomy of terms, knowledge graphs. You have output evaluation. So if even after doing all of this, sometimes the GenAI is unable to understand numbers, GenAI is unable to understand comparative quantities. So in that case, you need to have output evaluation. Then you need to have query optimization and breakdown. What does that mean is, if I'm having a complex query which is asking me about multiple concepts at once, then the GenAI, the orchestrator engine should be smart enough to understand that query, break it down into smaller concepts, and then try to answer those smaller concepts in parallel, or simultaneously, or in sequence, right? So that kind of query optimization and breakdown is needed. So it's not just that I have chunked and I have ingested data, I am throwing questions at LLM and LLM is able to, fantastically answer my questions. No, it's not that. This is how the, other kind of processing that is needed for a GenAI experiment to be successful. Okay. So what we did was, I'm going to show you the steps on what we took to kind of get to that level of accuracy. So our use case was, we had to, build this kind of an advisory bot for internal, client users to be able to answer the routine user questions, right, around Australian superannuation and Australian retirement policies. Okay. So we ingested, there were some 40-50 odd PDF files, 200-300 pages long. We ingested them, multimodal content. We had good chunking strategies, extraction strategies. So all that is done. So now our first question, after fair bit of testing around the evaluation test set. So one of the questions which failed was, can an 80-year-old make a personal injury contribution to superannuation, right? So you see, the bot, it fetched the correct corpus, it fetched the correct documentation, but it made a logical mistake. See, yes, an 80-year-old can make a personal contribution because it is not able to understand 75 and 80 in the quantitative sense, right? And this was done probably 1.5 years ago. So you didn't have all your super smart GPT-5s and 4.1 models. So this was GPT-4 vision, I think GPT-4, before GPT-4o. Nonetheless, it does not understand that 75 and 80 are numbers to be taken into account, and hence it makes a logical fallacy here, right? So what we need to do is, we need to then have curation of the brain. So what we do is, we have a champion challenger approach to be able to challenge the final reply and see that, hey, is it logical enough? Hey, is it comprehensive enough? Does it answer, the question with the corpus which is given, and is that answer logical, right? So that is the first step, where we do a self-ask champion challenger technique, right? So now after that, so after that, now when we say, can an 80-year-old make a personal injury contribution, then it says no, because now we have added that one step. We have also, in the previous step, we have also added one step, that can you ask clarifying follow-up questions, right? So if something is not clear to you, can you ask clarifying questions, or can you ask follow-up questions? So that is what we are doing. So, I'm going back. So then it says, no, an 80-year-old cannot make a personal contribution. It also gave citations correctly, and it also asked me follow-up questions like, what would you like to know further? Okay, and then the citations and so on and so forth. Okay, now next type of question rather, right? So we did this champion challenger self-ask, fixing logical fallacies, logical errors. So now next question is where it is not considering the surrounding parts of the question. So my next question, which failed was, my client has moved overseas permanently. Are they able to access the superannuation? Okay. So what RAG does is, it is going to create embeddings of your query. It is going to do a vector similarity, which is a cosine similarity between the embeddings which it has created in your vector database. It is going to fetch the most similar corpus, throw it to your LLM, get the completions, give you the result. Okay. So now it seemingly gave a correct answer, right? But this is totally rubbish. It's not related and it's incorrect. I mean, it's misleading. Okay. But this is what you could get because you did not empower the model enough with the surrounding context. Because this is a question about moving overseas permanently, which means the model, the GenAI bot, needs to have knowledge about, for example, your citizenship, your taxation rules, whether what kind of visa you are on. Are you, citizen of that? Are you a dual citizen, right? Because US citizens, they need to then, be liable for taxation in both the countries. So all of those complications it needs to address. So which means it needs to know about so many other things as well. Okay. Which then brings us to the concept of knowledge graphs. So for example, if my question is about deceased person benefits, then it implies that if that deceased person has a trust, then that trust might have beneficiaries, trust will have executors, trust will have trustees. The deceased person will be, basis of citizenship and other things, he will be subject to taxation. Okay, so if you take the previous question of intent of moving overseas, so you see that there will be residency status, departure status, conditions of release, withdrawal method. Okay, so an individual has a residency status, individual has a superannuation account, residency determines how you can withdraw your super, then departure status, whether you are a student and your visa expired and you moved, or you are a citizen and you moved, or you gave up your citizenship and you moved. So that departure status affects the withdrawal eligibility. Then withdrawal is subject to tax consequences, and then whether you're a temporary resident, you are a student, exited Australia, visa expired, those are your further conditions, right? So if I am an Australian citizen and then I have left Australia permanently, because I'm a citizen, which means my withdrawal method is subject to preservation rules. If someone is a temporary resident, they meet the DSP eligibility and it is granted if they have left and the visa has expired, and the withdrawal method might still be subject to tax implications, right? So when you give this kind of surrounding ontology or knowledge graph knowledge to the bot, so now if you see, when you give this context intelligence to the bot, then it will give you the correct answer. For your client who has moved overseas, the ability to access the superannuation depends on these criteria, and then it is finally giving you a correct answer, right? Comprehensive correct answer with the correct citations, with the correct conditions of release and withdrawal. Okay. So my point is, when you come to complex business use cases, so this is still one simple, not simple, this is one gated domain in which you are still bound within the superannuation retirement policies, and you might need to take care of certain extra concepts like residency and tax laws and your visa requirements, right? So these are still gated requirements. But come to complex domains where it is compliance, fraud, your PII data, CII data, governance, then there's a limit to the amount of data that LLM can crawl, right? Or the LLM can intelligently go and answer. Okay, so you have multiple data sources. You want the LLM to intelligently go and crawl those multiple data sources. It needs to know when to crawl what data source. It could be websites, it could be CRM data, it could be knowledge graphs, right? And then it has to intelligently crawl those data sources, aggregate the data, and present you the result. Okay, and building ontology knowledge graph, mind you, is not an easy task at all, right? So if you look at one sample ontology, right? So in the context of this superannuation ontology bot, which I was superannuation retirement bot, which I was showing, right? customer interaction types, because the questions could be around hundreds of things, right? Insurance cancellation, performance inquiries, like how is my portfolio doing, and should I switch my portfolios. It could be around investment options conversation, it could be around pension topics, it could be around insurance topics, right? So these are the broad level of topics on which your inquiries could be about. Okay, it could be about fees and cost, like, hey, I was seeing this amount of fee on my superannuation, what is the reason for that, or I have been charged indirect fee, admin fee, what are the reasons. So those kind of, it could be account closures and rollouts, it could be regulatory compliance related issues. So if we look at the ontology design, you see that if we were to map out the high level topics into actual entities, you can see that there will be risk, fee category, fees, market events, like, does the recent political events affect my superannuation growth, right? Or should I shift my superannuation from A to B? Or how does the current tariffs affect my superannuation investment? So these kind of questions. So market events, there will be disclaimers, because if my bot were to advise something, it should come with some disclaimers, because we are not giving personalized advice, we are still giving financial generic education. So there will be caveats around your market, your investments are supposed to are subject to market risk, and please be careful before investing, and so on and so forth, right? So there will be disclaimers, there will be conversation stage, like at what stage of conversation are you, like, are you a new customer, are you an old customer, do you have an advisor attached to you, or do you want to have an advisor attached to you, those kind of things as well. So you see, when it comes to constructing ontology, constructing those relationships between different entities in an ontology becomes a cumbersome task for you to then guide the LLM intelligently to be able to, good enough to know that these are my data sources, this is what I need to know, and this is where I need to go and fetch information from, right? And that is to solve a gated use case. Forget about, broad range use cases where you have thousands of documents, and you have multiple websites, and you have sublinks within websites which you have to crawl and which you have to maintain, and SharePoint systems and all other things, and this is still just unstructured or semi-structured data. Come to the point where you want to interact with your dataverse systems, or your Fabric data lakes, or your Azure SQL servers. Okay, that is where we want an agentic search to be made, an agentic RAG search to be made, and which is where the new Foundry IQ, which was released, it is trying to get to that point, right? It is trying to achieve that point. I'm not saying it's there yet, I'm not saying that all of these things you won't need to do. My point is, you will need lesser effort in getting to ingest information from various data sources. Okay, so with that being said, let's move on to have a look at what is Foundry IQ. By the way, how many of you have tried the new Foundry look? Have you had a look at new Foundry? Yeah, of course, JK. So this new Foundry look, so this was, let me toggle, right? Let me toggle. So this was your legacy look, where you have your models and catalogs and other things. Okay, so if we say, where is my toggle button? Oh yeah, here, yes. Yep. Okay, so this is how it looks like. So you have home, you have discover, you have build, you have operate, and you have documentation. Okay, so in discover, you will have your models, your tools if you have, and again, in tools you have a laundry list of tools available. It could be ones which are you have custom built, or one which are available out of the box. So you can see, yes.
Are these like MCP servers, the tools?
A lot of things, right? So this is so this is MCP. This is some custom library, or custom is MCP it is calling. So what I mean to say is, it could be MCP, it could be some other agents which you are according as tools.
So
you can have other agent connected to your agent as a tool, but whether or not you can make it available here, like discoverable here, or is it a marketplace offering? But I think yes, you should be under the custom. You should be, if you publish a agent as a tool, you should be able to access it here. But which means, you can't use it as an agent. You can use it as a plugin to an agent.
Oh wow, that's pretty cool.
Yeah, right. So you have your and again, provider within partner or Microsoft. So these are your tools available. Solution templates is another interesting thing, right? So you see that you have a lot of pre-built solution templates to get started with call center, to retrieve and summarize SharePoint, started with AI chat, conversational agent, modernize code with agents, a lot of things. Okay, that's your discover part. Models, as you know, it's all the Azure model catalog. Okay, the only other thing is, earlier used to have Azure AI service, OpenAI service as a separate project and Foundry as a separate project. Now it's all under Foundry, right? So all your AI services, all other models, everything will be searchable, available under here, right? Now let's go to build. So in build, you will have this new thing which is called as knowledge. Okay, and this knowledge is the basis of making your Foundry IQ available to your GenAI searches, right? So what is a knowledge? Knowledge, when you say knowledge base or that knowledge source is a collection of various data sources which you want to give as the knowledge source to your agent. So if you go back to our call center agent, the knowledge base for that agent would have been CRM data, website data, SharePoint pages, and whatever are the policy PDF pages for that particular organization. That would have been the collection of data sources which I'm consolidating and giving to the agent. Okay, so if you look at the knowledge, I've created, I have some knowledge base, right? You can create new, does not. So the knowledge base itself, you see, it's an LLM on the top, so that it knows, that when a query comes, where should I triage it to? Okay, so that knowledge base has an LLM on top. Okay, the knowledge base will be a collection of different knowledge sources. So it can have, so you can see here, if I see create new, it can support these many data sources. You can either add an existing Azure AI search index, blob store, web, SharePoint, remote SharePoint indexed, Microsoft OneLake data sources, and there'll be many more coming as the functionality gets more and more robust. So you can add many diverse data sources to one knowledge base. It is an LLM which will then, you will have the retrieval reasoning effort, like how much to reason to retrieve information from those knowledge sources. So your performance versus your accuracy trade-off, whatever you want. Okay, output mode answer synthesis, meaning I don't want raw data. I want you to combine answer from my various data sources, synthesize and give it to me, okay, in a proper natural language format. And I can have description, meaning what is this knowledge source for? So this is a collection of web files and SharePoint, and my SharePoint consists of my policies, and my website consists of data of my banking products. And when the question is about customer information, please refer to the CRM data. So those kind of instructions or metadata about your data. It could be plain English instructions as well. So just give an indication to the knowledge about what data your knowledge sources have and what is the priority of those. Fair enough? Any questions here? Okay. So once this knowledge, and I'll show you a proper demo, yeah, with actual knowledge policies and everything. So I'm just wanting you to get introduced to the concept of Foundry IQ, right? So this is the knowledge which I've created, and this knowledge, you see, I can directly use inside of an agent. So now my agent, in your previous Foundry experience, you could upload few files to a particular data source. It used to index it into an Azure AI search, and you could just add one data source to your agent, right? So now this entire collection of different data sources can be used as a knowledge source for your agent. You use in an agent. Okay, so I have created, let's say, 2 agents. I can use in either of those agents, or I can go to agents. Okay, let's say I will create an agent. Let's say SSW demo. Okay, and here in this creation, I can give whatever models I want, right? Whatever I have deployed, instructions, tools, which is like existing knowledge corpus or some of the existing tools which I saw, and you see knowledge. Knowledge is now from the knowledge bases which I have, right, which is a collection of various data sources. So I can give that as a knowledge, and then it will operate on my knowledge. I can have memory also. Yeah, so see, create memory store and guardrails. I can also give guardrails if I want to, give some content filtering, red teaming kind of instructions, content monitoring kind of instructions. All right. So let us see the Foundry IQ properly in action. And this is, by the way, official demo from the Microsoft Foundry Ignite demos, right? So if you look at this, I showed you this knowledge, right? Here, the knowledge. So here you can see that I have these many disparate knowledge sources. It could be blob, okay? Oh, by the way, another side note. How many of you know or have worked with the fictitious company called Contoso before? Right? Okay, so Contoso is dead. It's replaced. It's replaced with Java. Yeah, Java. So we actually got T-shirts, for Java during the keynote. Well, I didn't get because I didn't join the keynote, but people got T-shirts of Java. All right, so Contoso is officially replaced by Java now. So you have Java, which is one of the knowledge source, which is just blob. Then you have another financial knowledge base, okay, which is a combination of two blob stores. So it is financial bulletins and financial filings. You have healthcare knowledge base, which is again collection of two sources. You can see here two sources, okay. Let us look at more complex sources. Why it's not scrolling? Really? Okay. You have manufacturing knowledge base. You have One Lake, which is, just One Lake files. You have Ontology, which is MCP, okay. And then you have something called as Java knowledge base here. This Java knowledge base, let us view it. So Java knowledge base is a collection of, so as I said, it's a LLM on the top. Output modalities, raw answer or answer synthesis. Then I've given it description, right? So Seattle store performance data, blah, 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 answer instructions. And these are my knowledge sources. So you can see my knowledge sources are these ones: Java blob, One Lake files, and Java web, okay. And my retrieval configuration is what I'm asking it while retrieving, what it should be aware of. So queries about, for queries about search, you will refer to One Lake. For query about personal information, you that is in M365, you would go to remote, SharePoint, and so on and so forth. So I'm giving those very high level retrieval instructions, and this is my knowledge base, okay. Now let's go to the agents, okay. So I've created a Java knowledge base agent on top of my knowledge base, right? And now let us have one query, which is like a complex query, which is multimodal, right? I'm giving an image, right? And I'm asking complex, like, use this image of global production, and then using the Java knowledge base, explain how supply chain works, and then, which of these facilities would face the biggest operational risk if there was a marathon scheduled during the weekend, and recommend adjustments, right? So it's taking its time. So you can see on the top, it is this knowledge base it is using. It has 3 sources, okay. Okay, great. So let me show you the magic of Foundry IQ. So this is our answer. We got this answer. Fair enough. That's not the magic, right? The magic is here. It gives me a retrieval trace. I got iterations, so which means it tried my query 2 times, okay. It tried to optimize the retrieval 2 times. 20 activities, which is aggregate phases processed, 94 retriever calls, 598 planning tokens, and 26 seconds it took. It broke down my query. So you see this query in the iteration 1, it did a query planning. It decomposes the user request and selects the sources and drafts search variants. So it broke down my user query, and see, it actually shows me how it broke down and what data sources is searched against. You see, so it One Lake files, then it went and looked at web files, okay. And then in the second iteration, again, see, query planning, retrieval, assessment, synthesis. It did a second iteration, and now it also went and searched, the what was that? Yeah, so it went and revamped my search, okay, and then effort, it said okay, my effort was medium, okay, and then finally it gave me this answer. This gave me the answer, it gave me the referenced material, okay, and it gave me the, like for example, if I click on those, it is giving me those sub references which it has used, and that's it, right? So now you can see that agentic retrieval is supported out of the box. I don't have to make an extra effort for it to, with that champion challenger approach which I had earlier, where I had to prompt it and say, oh, is this accurate enough, is this grounded enough? So this agentic retrieval is supported out of the box, okay. So it is underneath, it is still Azure AI search. It's not like a new service which you are creating, right? So underneath it is still Azure AI search. So to create a Foundry resource, you will require an Azure AI search. But the kind of indexing and embedding it does is on the fly. Okay. So you can see end-to-end observability, agent controls, secure every agent, command, connect every agent, and so on and so forth. Okay. So when you say knowledge graph, right? Knowledge graph functionality of Foundry IQ. So Foundry IQ out of the box is going to support these many data sources which I showed you here.
Yes,
When
I'm not talking about that. I'm talking
Yeah.
about the context aspect of it.
Yeah, so context aspect meaning the one which how it retrieves out of the box, or the one which I showed you that we have to build all
So
the
example
ontology.
will be that.
Yeah, yes. Yeah, that is still that is still custom built for me, right? So I'll need to build my ontology, and I will need to put it into Microsoft supported, like either it is an Azure AI search index or Microsoft OneLake, where it can refer to those data sources, right? So and later on it will be Neo4j as well. It is not yet supported, but it will be Neo4j and Cosmos DB and PostgreSQL, and all of that will also be supported. But for now, if you wanted to create a knowledge graph, ontology knowledge graph, you create it, you put it into Microsoft OneLake, and give that OneLake as one of the knowledge sources to your knowledge base, right? So that creation of the ontology is not automated, because that cannot be automated in the sense that it is use case specific. If I'm working for a banking domain, it will be a financial ontology. If I'm working for a healthcare domain, it will be a healthcare ontology. So that first level of creation could be, could be agentic or automated, in which you are inferring the topics and you're trying to build those entity relationships at a high level. But otherwise it is use case and domain specific, right? So that ontology itself won't be automated. That you will have to go and build using ontology tools or Neo4j, and then input it in one of the supported data sources, and then give all of that to your agent as a knowledge base. See, previously the demos which I showed you, what was happening was, I had multiple agents querying the multiple knowledge sources, right? But they had no connection of now which knowledge source should I go into. Like I have this huge query, it needs to break down that query. I myself needed to do that. I had to write an orchestrator in which it is taking that complex query, it is breaking it down into subqueries. Then each of the supervisor agent or the orchestrator agent is responsible for orchestration of those sub agents into different knowledge sources, and then getting the answer. And then if the answer does not meet my accuracy criteria, I have to, anyways debug, and I have to do prompt tuning and prompt engineering. Now with this, all my orchestration, query breakdown, query planning tasks are offloaded to Foundry IQ. That first level of orchestration, query breakdown, planning is done by Foundry IQ. The knowledge bases, however you want to curate it, like how rich you want it to be, how contextualized you want it to be, that is still how you curate those knowledge sources and give it to the agent. But now that agent has visibility of 3-4 of your knowledge sources, Foundry IQ is doing your query planning, decomposition, and giving you, enriched results with the help of your Foundry IQ agentic retrieval.
Okay, so right. So it's fine. So the second one is, I think in the earlier presentation you talked about quite often people go from POC and they come really go into production. They're dealing with, rather than 10 documents, they're now dealing with 1 million documents.
Correct.
Okay. So do you have sort of how does this actually solve differently if you were to code it yourself? How does it overcome that scalability issue?
Yeah, so right now Foundry IQ is in public preview, so it would be GA sometime next year, right? Yeah,
So
next.
it's not even available.
Yeah, it's in preview, public preview. It's available. It's public preview, but it is not GA yet. So when you talk about data sources which it right now supports is probably those 4 5 which I showed you, right? As to the question about scalability, production deployment, those, as I said, your first level of thousands of documents, being a part of your knowledge base, those could be directly done from the portal itself. How much control you want over your chunking, context rich features, so it's a trade off. You need to decide whether I want to have full control of how I chunk and enrich my document corpus. Then you are better off using your custom ingestion pipelines and ingesting data, and once your data is ingested, you can just give that Azure AI search index to Foundry as one of the data sources. If you want.
Sorry, my question is more about the scalability.
Hmm.
So not about the exact chunking things.
Yeah. So scalability, once it is GA, right? Once this is GA and this is going to support multiple data sources, there should not be any issues around scalability because it supports Azure AI search, which can support multiple thousands of indexes, thousands of documents. It supports OneLake. Sorry, what happened? It supports OneLake. It supports SharePoint. So that scalability should not be a problem. Thus, the worry should be accuracy in the sense that how much accurate it can get with the out of the box capabilities of just dragging and dropping those knowledge sources. So scalability, once it is GA, should the limits, the elasticity of the limit should not be a problem, to answer your question. Okay. Okay, so another part is, now you can publish your agents, and you can see while publishing the agent, there is an option of publishing that agent directly to teams of or M365 Copilot, right? So you have that option of, composability of that agent into your existing Copilot or teams as well. Okay. Let me go back. Sorry. Okay. Let me go back to the knowledge ecosystem. Okay, let me look at one of the other agents. Oh, come on. Yeah, so to answer your question on the ontology KB, right? So you see, for some of the ontology, it has actually piped into MCP, where it is querying some existing probably Neo4j or Databricks related tool. So to create that ontology, you can create that ontology as an existing Neo4j or whichever supported type, and you can pipe it using MCP as well. So the creation of ontology is not out of the box. Piping that source as one of the data knowledge sources will be the strength of Foundry IQ, like bringing in diverse data sources together. Okay. Really. Okay, let's go to that manufacturing knowledge base, and let us look at one of the other playgrounds of, let's say, financial knowledge base. Okay, so you see fact sheet analysis with image. Again, multimodal content, upload screenshot of okay, this is where I want to upload a screenshot and then summarize some things. So maybe I go back to the playground. Okay, so if there are images and if I want to have maintenance questions on those kind of image documents or policy documents, same thing. So now here it did not need to have more iterations because simple query, maybe it knows one or two data sources alone. So there it did not go into that onerous planning and retrieval and all of that. One shot it was able to answer your questions, right? And then it will be able to give you your iterations and so on and so forth. And if it does not find anything, it will again say that no relevant content was found for your query. So fair enough. Again, retrieval calls, it did not do anything because it did not find anything relevant as well. Okay. So Foundry IQ is still evolving. Again, you can directly go on to the GitHub to look at some of the samples and some of the open source examples given there. Okay. And by the way, this Foundry IQ demo is actually a website which is built on top of the Foundry IQ feature, right? So this is your Foundry IQ feature on Foundry. on Microsoft Foundry. And then this demo is actually a Azure website which is built on top of that feature to be able to showcase the power of those session tokens, telemetry, observability, query planning, iteration. Okay, and if you go here, it also will be able to look at some of the retrieval instructions, answer instructions, knowledge source parameters, okay, so on and so forth. So this is a web app which is curated on top of the Foundry IQ feature. And again, when you go to the GitHub, you will be able to have instructions to deploy this and then curate it with whichever data source which you are deploying in Microsoft Foundry. Okay, any questions? Yes.
So, two questions. The first one is when we put information into as a knowledge, assuming it's like a PDF or POC doc, etc. Is it only the text that's actually doing, or does it actually interpret a graph or tables?
So as I told you, right, the content which you are giving basis the model which are, so here is GPT 4.1 or something, which are all multimodal content. So everything goes. So that if that PDF is text and graphs and embedding of all of that will be done. So that document, it's when Foundry IQ is searching the document, Foundry IQ is based on top of Azure AI search. Okay, so Azure AI search, when Foundry IQ is retrieving content from the document at runtime, okay, it is actually creating indexes in memory on the fly. So all that content which is images or graphs or everything, and if you want vectorization, it will also ask you that, do you want to create embedding models, which means it is supporting multimodal content. Whether if you want only text to be extracted, if you want vector embeddings of, your image to be there, all of that you can do in Foundry IQ.
So the second question is there a website or something documenting the roadmap? What sort of things you plan to sort of add, or is it something more like a company secret we won't know until it's in the
Yes.
So the reason why I ask that is, like if we start coding things, and then you guys are going to come up with a tool in say 6 months' time, there's no point for us to.
Oh, by the way, I'm not Microsoft, right? So, yeah. No, look, to be honest, none of us have any idea on these kind of things. And even if we do, like, me and JK might have certain idea, but we are under NDA. So even Foundry IQ, this name, we knew it since like, I think 2-3 weeks in advance that Azure AI search, agentic search is now going to be called Foundry IQ. We could not disclose it. We are bound by NDA. So there is a roadmap, yes, and a lot of interesting features to be added in the roadmap, but we are not at privy to discuss. Or sometimes even we don't know the ETA, like, is it January, is it, February, is it March, is it going to replace semantic kernel, is it going to embed Microsoft agentic framework?
No, that's good. Thank you.
All right. Yeah, okay. So you can go to ak.ms Foundry IQ. You can feel free to experiment with the new Foundry capabilities. There's observability, there's evaluation, there's diagnostics, there's Microsoft Agent Framework as well. So another interesting, open source engine for building, orchestrating intelligent AI agents. Okay, and ChatKit, Copilot Kit integration is in public preview. Purview SDK integration is now out of the box. So feel free to, play around with all of these interesting announcements, and good luck in building your RAG agents. Thank you so much.
So I'm going to do a quick spiel about our 2 extra sponsors for this evening. If you have any questions, just get your phone out and start writing them out now. So, first one is Tina CMS. Has anyone heard of it? You have? Yeah? You? Wow. The people in the company, isn't that nice? So Tina CMS is a content management system. You can head over to tina.io. It's all hosted in GitHub, and it brings you an intuitive little editor where you can edit your content in real time. The other one is Yakshaver. It's an AI tool, actually. That helps you get your PBIs from in your head to in the right backlog as best you can. So if that sounds like you've got problems in your company for getting PBIs in the wrong places, head over to Yakshaver AI and see if it's the right tool for you. So, anyone got any questions for Priyanka? No? There you go.
Do we have control over the UI or
For
Foundry IQ provides us?
No, I mean, look, Foundry IQ, like Azure AI Search, is a service, right? So you use it as an API in whichever UI you want. So it will have a basic web app where, like a chat interface, the one which you saw. That's about it.
amazing. Oh,
Yes.
you go.
Yes.
My question is about like, in the different business logic, maybe there are multi steps of the process. So how did you handle it? Because maybe there are some report generation or some like data retrieval, maybe about the financial domain, sensitive data. How Foundry IQ handle this? Because just want to know like multi-agent, how they communicate with HR.
Yeah. So look, Foundry IQ is a service on top of your knowledge sources, right? How would, if your AI search otherwise would have sensitive data, or your PDFs have sensitive data, how would you feed them into into AI search? You would first run an extraction, then you would identify PII entities, you would mask them, then you would ingest them into Azure AI search. So similar things, right? So Foundry IQ out of the box is just a knowledge source of collection of diverse knowledge data sources with an intelligence of routing intelligence and agentic retrieval. So it's a indexing retrieval smart planner engine, right? That's all. So compliance, PII data, how multiple agents should use Foundry IQ, or if there's a report generation step, so you've built a Foundry IQ knowledge base, you have given it to an agent. Okay, so now after it retrieves that information, it should go and do some report generation. So that is an agent responsibility, which means that report generation should be a plugin given to an agent. Foundry IQ is just a knowledge indexing retrieval smart planner service. Okay.
So it's like a strong tool you can integrate with other different agents.
Yes, correct.
Oh,
So
great.
yeah, so it's a smarter way of doing Azure AI search. Let me put that, right. So right now your Azure AI search could handle one data source at a time. Like you can create an index of PDF documents. You can create an index of websites. You can create an index from SharePoint. Okay. Now with Foundry IQ, imagine that you can create one Azure index comprising of 4 or 5 document sources, and your agent will have intelligence of all those 5 sources to answer your query real time. I mean, to answer your query, complex query, and search all those 5 knowledge sources. That orchestration complexity is offloaded to Foundry IQ. To some extent, let me clarify, right? It's not like it's super smart and super simple. You will still, for complex things, you might need to do some add-on stuff. But now your Azure AI search is comprising of diverse document sources and is aware when it is running the query that I need to go through these 5 data sources without me having to add additional layer of logic around, hey, understand the user intent. Then if the user intent is about his login information, you go to this data source. If it is about policy information, you go to the web site data source. No need of those things. Okay. Any other questions? Yes.
Agents allow nesting? Like in
Yeah.
Binance,
Yeah.
Agents with other agents?
Yeah. I can show you that here itself.
Big question.
Sorry, can you repeat?
The question was around, does it allow agent chaining, right? Like multiple agents, one agent to another agent. Okay. So yes, it does. Let me show you here. So this is your agents, right? Sorry. This is the agent which you created. So in the tools, when you say add, right? So you can add all of these things. So Fabric Data Agent, grounding, computer use, web search, SharePoint, browser automation, Azure AI Search, Code Interpreter, right? Or you can see custom, right? So you can create your own custom agents. You can be able to pipe them into this. So you can have multiple agents added to one agent. That is irrespective of Foundry IQ. Foundry IQ is the knowledge source. Tools will be the end actions which you are taking, right? So yeah, agent chaining is irrespective of Foundry IQ. That is the point.
Thank you.
Any other questions? Yes.
I just have a question about Azure AI search. Do we have the choice between using navigable small worlds and exhaustive search? Is there other options?
So that is the, in Azure AI search, you will have settings, programmatic settings, which you have to do. That HNSW, highly navigable small world, and the algorithms which you set, right? So in Azure AI search, when you're configuring those things, so Foundry IQ is, when you create a Foundry IQ resource, you need an Azure AI search service created. So that Azure AI search service, you configure it using your, SDK, and you set whichever algorithms you want to, like KNN or HNSW.
Okay, so we can use whatever.
Yeah, exactly. Yes. Any other questions?
All right, awesome. Cool. So I've mentioned the other two sponsors, but the other big one that's obvious is SSW, the building we're in. So thank you to them for hosting. Very, very gracious of them. And the last one, biggest thank you of all, Penny in the back for organizing all of this for us. If you guys are interested in any careers or working at SSW, slight shill, I do work here. Go talk to Penny, not me, please. Yeah, and thank you so much again for the talk. Very, very good.
Thank you all. Thank you so much for staying in so late.
Excellent. Puff, right?
Thank you, Penny and SSW again.